For centuries, people have told stories explaining moving lights in the night sky. The curtains of greenish-white light with pink fringe. People described these lights as the breath of the earth, powerful spirits, or angel light. An early 20th century explorer wrote about the bloody red and ghostly green lights. These lights, of course, are the aurora boreal, boreal, the aurora boreals, boreals, the northern lights, and in the south, the aurora australis. Most of the time they are greenish yellow, but sometimes they take colors. They take colors. Colors. Colors from violet to red. The auroras can be seen at any time of the year, with the right atmospheric condition. With the right atmospheric conditions, they are most often seen near the north and south poles during a time of maximum solar activity. The closer to the north or south pole you are, the better you can see the lights. The aurora, aurora, aurora. Hmm. Sorry, the aurora occur in the ionosphere. Ionosphere. The ionosphere is the layer of the upper atmosphere where high-energy solar radiation strips the electrons from oxygen and nitrogen atoms. Radiation strips the electrons from oxygen and nitrogen atoms and leaves them as positively charged ions. The auroras are the result of a complex interaction between the solar wind and the Earth's magnetic field. Here's what happens. The sun's heat charges the particles in the solar wind. A stream of electrically charged subatomic particles that continually emanates from the sun. As the solar wind approaches the Earth, it's deflected by Earth's magnetic field and diverted north and south toward the magnetic pole. The interaction between the solar wind and the magnetosphere generates beams of electrons. electrons. Now, these electrons collide with atoms and molecules with the ionosphere near Earth's magnetic poles. The collision collision rip apart molecules and excited atoms. Thus, oxygen and nitrogen atoms in the ionosphere become excited and or ionized. The auroras happen when these ionized atoms return to their normal state from their excited, energized states. This ion combine with free electrons. As they do so, they emit radiation. Part of this radiation is visible light, the aurora borealis and aurora australis. Yes, Simon? It sounds kind of like electricity. Yeah, that's right. The auroras are an electrical phenomenon. やっぱり鳥にだよね。Electrical phenomenon. As you know, an electrical generator has two components, a conductor and a magnetic field. To generate electricity, the conductor has to move across the field to produce a force. With the auroras, the conductor is the solar wind carrying a stream of charged particles. So what happens is when the charged particles reach Earth's magnetic field, they move along in the field towards the north and the south magnetic poles. Exactly, and then the particles collide with the gases in the atmosphere, oxygen and nitrogen. And the oxygen and nitrogen atoms get excited, and then when the particles get de-excited and return to their normal state, they emit the auroras by releasing energy in the form of light. Oxygen releases either dark red or ghostly green. Nitrogen emits rosy pink or magenta. The activity of the auroras varies with the sun's activity. When the sun is quiet, the auroras can be seen only in a small area. When the sun is active, however, the auroras can be seen across southern Canada and the northern United States.